Okay, hello everybody. This is Mrs. Masteller again. We're focusing on now today is adding and subtracting rational expressions. So we already did multiplying and dividing, which I think personally is easier, but adding and subtracting requires a little bit more work. But I just want to kind of recap and review with you how do you actually add and subtract two fractions. So if I had something like 4/5 and I'm trying to add to it, let's just say make something up. Let me say I'm doing 3/7. Okay, if I want to add these two together, if you're trying to add two fractions or subtract them, you need a common denominator. So these have to be perfect matches. So how you find the common denominator is you're finding what's called the LCM. That's called the least common multiple. Okay, so you're thinking multiples, not factors, but multiples. So we start listing out the multiples of 5. You have 5 times 1, 5 times 2, 5 times 3, 4, 5, 6, 7, 8, so on and so forth, right? And then listing out the fact or the multiples of 7, you have 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and I'm going to stop there because I see their LCM. The LCM would be 35. So basically what you're trying to do is you're trying to make each of these denominators now to be out of 35. So to make a 5 into a 35, well, that's times 7, but I'm also multiplying the numerator by 7 too, so the whole fraction changes. So that would make this 28 over 35. And then I'm adding to this to make that 7 into a 35. Well, that's times 5 on the top and bottom. So again, the whole fraction changes, making this 15 over 35. So once you have your common denominator, now you just need to add your two fractions. So you keep the denominator, 35, and you just add going straight across now in your numerator. So 28 plus 15, so it'd be 13. Then you carry the 1, so 2, 3, 4, 43 over 35. Okay, so that's what we're going to be focusing on today is getting your LCM, get your least common multiple. So same thing. Uh-oh. Same thing, going back over here. So these first few examples, we're just trying to find the LCM for each pair. So pretend like these are denominators. Pretend like the first one, example 1a, pretend like this says 3 over 4x squared y cubed. And then you're trying to add to this, let's just say 5 over 6x the fourth y the fifth. Okay, so pretend like these are denominators. You have to get your LCM. So between 4 and 6, the LCM would be 12. So that's the least common multiple they have. The x's, so you have two x's here, you have four x's here. You can't take away x's. You can only add more x's. So again, the first one only has 2, the second one has 4. Well, we can make this x the fourth if I just multiply by x squared over x squared. So basically, the higher exponent, x the fourth, takes over. So x the fourth would be my LCM. And then the same thing with the y's. I have 3 y's and then 5. I need the higher of the two. I need y to the fifth. So that would be my LCM. Okay, same thing for b. Get your LCM between 4 and 3. That'd be 12 again. Looking at my x's, 3 and 5, I want the bigger, so x the fifth. Y's, I need the bigger, which is y the seventh. That would be my LCM. And then for C and D, we got to factor these, and then we'll kind of take a look at them and see if they have anything in common right now, and then we'll add anything additional if we need to. But factoring my first trinomial, that'd be x minus 3, x plus 1, and then this would factor into x minus 3, x plus 2. So you can see they already have x minus 3's in common. So that's a part of my LCM at x minus 3. But now you want to multiply every single binomial together. Okay, all the binomials, you want to make sure they're all accounted for. So all three of these multiplied would be your LCM. X minus 3, x plus 1, x plus 2. And same thing for D. So if you factor this, this would be x minus 2, x plus 2. Difference of squares. And the second one multiplies or factors into x plus 3, x plus 2. So once again, they already have x plus 2's in common. That's part of my LCM. And then just multiplying with the other additional binomials, all three of these multiplied would be my LCM. Okay, it's going to make more sense too once you guys see these worked out as far as finding the LCM. For some reason that's always confusing at first, but once you see, again, getting your common denominators, this will all kind of come together more. So for the next examples, example 2, going all the way across, it just says to add, and it says to assume that all expressions are defined. So we don't have to say what x cannot be equal to. We're just adding or subtracting, okay? So going straight across the board, first thing you're looking at is the denominators. Do they match? And in all four of these, you already have common denominators, so that makes it pretty easy. So like for the first one, you already have common denominators xy, xy. So again, you keep your denominator, but now I'm going to add going straight across my numerator. So I'm really just combining like terms. So 1x and 3x is 4x, 5 plus negative 1 is 4, and that would be your solution. Okay, you add it, you're done. The next one, same thing. So I already have my common denominator, so I'm going to keep the 12a squared b cubed, but now I just need to subtract going straight across. 5 minus 8 is negative 3. And now the last thing we could do in this problem is we can actually reduce this. So negative 3 over 12, we can cancel that down to be negative 1/4. So negative 1 over 4a squared b cubed, and that would be our final solution. For C, again, you already have your common denominators, x plus 4, so we'll keep our denominator, just add, go straight across, combine your like terms, you'd have 2x minus 5, and that's about all I can do. And then same thing for D, you have your common denominators, so I'm going to keep x squared plus 1 on the bottom, but now when you subtract, you're subtracting the whole entire numerator. You're subtracting 6x and then also 1 from their like terms. So a 3x minus a 6x is a negative 3x. Negative 4 minus 1 makes that negative 5. So there's my solution. Okay? So again, when you have common denominators already, that makes it pretty easy, right? You just need to add or subtract, go straight across. But obviously we're going to have examples and problems where we don't have common denominators. So we have to make them common. Okay, so all four of these examples, it says to add. These are all addition problems, and then identify any x values for which the expression is undefined. So we'll get to that part in just a second. Okay, but for the first one, get your common denominator. Between 2 and 5, the LCM would be 10. So to make that into a 10, the first fraction needs to be multiplied by 5. Second one needs to be multiplied by 2. Okay, so that gives me the 10 on the bottom. Now look at the variables. The first one has an a. The second one has a b cubed. So the way I look at it is I always try to think about which one or what does each fraction have that the other one doesn't. So for example, the first fraction has the a in the denominator, but it doesn't have the b cubed. So the first one needs b cubed. The second fraction has b cubed. What it doesn't have, though, is a. So it needs an a. Okay. So now we have to actually do the multiplication. So with the first fraction, multiplying the numerator and denominator by 5b cubed, you would have 15b to the 4th over 10ab cubed. And now we're adding to it, second fraction, doing your multiplication. This would be 14a cubed over 10ab cubed. So again, take a step back and look at it. You just got common denominators. If you look at your denominator, they're perfect matches now, 10ab cubed, right? So now again, you keep your denominator, 10ab cubed, and now we're going to add going straight across the top. But we're not actually going to add these two because, well, they're not like terms. It's a b to the 4th and then a cubed. So it's just going to stay as one giant fraction, just like this, 15b to the 4th plus 14a cubed, and that's all over 10ab cubed. Okay, so we got our solution. Again, they do want us to state what makes it undefined. Technically, we have two variables. A cannot be 0 in this case, and b also cannot be 0 since they're all being multiplied. So it's 10 times a times b cubed in my denominator. As far as multiplication goes with a monomial, a and b both cannot be 0. Okay, so for the next one, what we have to do for this one a little different since it's not monomials, we got to factor. So if I factor this one out, that would be x plus 4 and then x minus 1. Okay, so take a step back, take a look at your denominators. They already have x plus 4s in common, right? But the first one has an addition, it has an x minus 1. So the second one still needs x minus 1. Okay, so there's our game plan. We're getting our common denominators. So first fraction's not changing, besides the fact that you have a factored denominator. But the second one, again, we're multiplying the numerator and denominator by x minus 1. So on top, you got to distribute. So we're adding 2x squared minus 2x. And this is all over, again, my new denominator is x plus 4x minus 1. Okay, so we have our common denominators. We got the first step done. Now we have to actually add going straight across. So I'm going to keep my denominator. And now my numerator, when you add going straight across, you would have 2x squared. You got 1x, and you're adding to it negative 2x, so negative 1x, and then minus 3. Okay, so technically we are done. We did add the two fractions together, so mission accomplished. But you should also check to see, can I do more in this problem? Can I actually factor my numerator to get something to reduce down as my overall answer? And yes, you can factor. So if you factor that 2x squared minus x minus 3, it factors into 2x minus 3 and x plus 1. And then your denominator stays. But as you can see, it doesn't really lead you anywhere. So as far as factoring goes, nothing's going to cancel, right? That's kind of the overall goal. And once I get to my final solution, can I actually reduce my answer once I have it factored? And the answer is no. But typically, your teachers probably would like to see this is your solution versus the other one. Technically, they're both your solution. They would both kind of count as being your solution set, but this is probably the more preferred one. Again, they probably want to see you at least attempt to try to factor, to try to reduce, and try and simplify your overall solution. Okay, so we have our solution set. Again, stating what makes this undefined. In this case, x cannot be -4 and x cannot be 1. Those two values make it undefined. Okay, so just because I write a little too big, I'm going to erase everything I've done so far. So hopefully you guys are all up to speed to go through the next problem with you guys. So let me erase. And now looking at C. So again, looking at my denominators, they have to be matching. Right now they're not, but factor what you got so far. Take out a 3 here, that'd be x minus 5. Take out a 6 here, and that's an x minus 5. Okay, so looking at my denominators again, they already have x minus 5s in common. They both have x minus 5. But the GCF in the front, you have a 3 in the first fraction and 6 in the other one. If you think about it, you can make a 3 into a 6. I can make a 3 into a 6 by multiplying this first one by 2. Okay, so that's my game plan. I'm getting my common denominator. I'm going to multiply that first one through by 2. So on top, I'm going to go ahead and distribute, making that 2x plus 20. My new denominator is now 6 and then x minus 5 plus nothing changed over here. So I'm just going to recopy down what I have. Okay, so now we're all set. So going across my denominator, I'm going to keep that 6x minus 5. And now we have to add going across. So 2x and 3x, that would make that into a 5x. 20 plus 15 is going to make that 35. And again, try to see now. So again, we're done. We have the answer. We add it. But try to see, can I factor and cancel? Can I do more work? On the top, you could take out a GCF of 5. And then you'd have x plus 7. And then you'd have 6 over x minus 5. So again, technically, didn't really lead us anywhere. Okay, once we do factor, but this would be your final solution. Okay, and then the one value that makes this undefined would be x cannot be 5. All right, and then for the last one, again, factor out your denominators, see what you got so far. So the second one is x minus 2x plus 2. So again, they both have x plus 2's in common, but the first fraction needs the x minus 2. So I'm going to go ahead and set this up. First one just gets multiplied by x minus 2. So on top again, distribute x to both terms, making that x squared minus 2x. My new denominator is x minus 2x plus 2. And the second one is not changing. So I'm just going to recopy this all down. Okay, so now we have our common denominators. I'll just rewrite those. I keep my denominator, and now we just want to go straight across the numerator, adding and subtracting, combining like terms. There aren't any, so what this would be on top is just x squared minus 2x minus 8, which just even looking at that, I know that's factorable. So thinking about how this factors now, that would factor into an x minus 4 and x plus 2, which looks promising because it looks like something is going to actually cancel in the end. But before you cancel, again, this is when you want to state what makes it undefined. Before anything disappears on us, tell us what makes this function undefined. That'd be positive and negative 2. Now from here, canceling x plus 2's. So your final answer would just be x minus 4 over x minus 2. That'd be your final solution. All right, so there's addition. Now let's move on to subtraction on the next page. So we're doing the same process, except now we're just subtracting. So we still need a common denominator before we add or subtract. So same rules apply. So looking at the first one, it's obviously kind of a mixture. You can see addition with the first two fractions, and then you're subtracting the third one. So looking at denominators, you got 7, you got 5. Technically, you have 1 here, 1x squared. So the LCM between just all the numbers would be 35. So the first fraction, I'm going to times this by 5. The second one, the middle one, I'll times that by 7. And the last one times 35. Okay, so I got the numbers covered. Now look at the x's. The first one has none, the middle one has 3, and the last one has 2. So the first one needs all 3 x's, x cubed. The middle one is set, but the last one needs one more x, so it needs an x as well. Looking at the y's, you have 2 y's, and then you have 1 y, and then you have none. So the middle one needs one more y to make it y squared, and the last one needs both. It needs y squared. Okay. So then I have it set up. I know what I'm doing now to actually do it. So my first fraction is now going to be 15x to the 5th. My new denominator is now 35x cubed y squared. Okay, so now we're adding to this. The next one multiplying would make that 56y. My new denominator again should be matching the first one. We have 35. We do have x cubed, and then y and y makes that y squared. So far looks good. And now we're subtracting. The last one, 3 times 35 is 105. We do have the x, and then we have y cubed on top. Underneath it, this would be 35x cubed, because you got x squared and x, y squared. Okay, so now we have our common denominator. You can see it clear across the board. So I'm going to keep that all intact. And now just all the way across the top, you would have 15x to the 5th plus 56y minus 105xy cubed. And that would be your final solution. And I believe we also have to state, yes, it does. It says to identify any x values for which the expression is undefined. So again, you have 2 variables. So x cannot be 0 and y also cannot be 0. Those are my 2 undefined values. Okay, so for the next one, get your common denominator again. So for b, factor this out. You'd have x minus 3x plus 3. So now take a step back and see that they both have x plus 3. So the second one needs still x minus 3 on the top and bottom. Okay, so first one's not changing. I'll just recopy it. First fraction all stays the same, but the second one, distribute on top. We're subtracting 5x minus 15. And again, my new denominator has both binomials. Here we go. Okay, so we have the same denominator. They may not be in the same order, but they are matching pairs. So we have our common denominator. So now just keep that, x minus 3x plus 3. And with subtraction, again, you got to be careful because you're subtracting 5x, then you're also subtracting negative 15. So that would actually be negative 3x plus 15 in my numerator. Okay, so we have our answer. I would check to see, can I do more? Can I factor? You can at least take out a GCF on top. I would take out negative 3. Then you'd have x minus 5, and then your denominator stays the same. But again, obviously nothing's going to cancel in this case. So that'd be my final solution set. And then once again, what makes this undefined would be positive and negative 3. Okay. Last and final one. So I'll just kind of pause here, make sure everyone's all caught up. Make sure this all makes sense. And once again, I am going to erase everything. Just give myself some more room. So for the last one, get your common denominators. Factor these out. This would be x minus 8x plus 8. The second one factors into plus 8 minus 3. Okay, so they both have x plus 8, but they're each missing something this time. The first one needs x minus 3. So I'll get that one set up. And the second one needs x minus 8. Okay, so doing the multiplication. First fraction, distribute on top 2x to both terms. So that'd be 2x squared minus 6x. And my denominator again is all 3 binomials, all 3 of these guys. Okay, then we're subtracting. Second one, multiplying on top, distribute, you'd have 3x minus 24. And again, all 3 binomials, doesn't have to all be in order, just basically as long as you have all 3 of them. Oh, it's supposed to be an 8, x minus 8. All right, so we have our common denominators, we're all set with that. Now, keep the denominator, keep all 3 of these together. This is your new denominator. and now actually do the subtraction. So again, you're subtracting 3x, and then you're subtracting negative 24, so you'd have 2x squared. Negative 6 minus 3 makes that negative 9x plus 24. And now just check to see one last time, can we do more? Can we factor that numerator and get this to reduce down? The answer is no. You cannot actually factor that numerator, so that'd be your complete solution. And then what makes this undefined would be positive negative 8 along with positive 3. Okay. Last one's now complex fractions. It says to simplify and assume all expressions are defined. So I'm going to break this up kind of into 3 problems altogether. The top part first, so let's just deal with this. Ignore everything else for right now. Let's just add these 2 together. So 1 over a plus 1 over b. Well, again, if I want to add 2 fractions, I need a common denominator. So the first one has an a, it doesn't have a b. Second one has a b, doesn't have an a. Okay, so what do we have? We have b over ba, or ab, plus a over ba. Now we have our common denominator. So this would just be b plus a over ba. Okay, there's the first part. Now let's take the bottom. Let's do that separately. So we're doing 1 over b minus 1. I'll just put it over 1. So again, subtracting with fractions, need a common denominator. The second one needs a b. So multiply the second fraction by b over b. So this would be, in the end, so we have 1 over b minus b over b, and that would be 1 minus b over b. So there's my denominator. Last thing we're going to do. Okay, what you're doing is you have the top divided by the bottom. So with division, so I'm going to take this result and this one and now divide them. So how do you divide? Well, you keep the first one all the same. We're going to multiply by the reciprocal, b over 1 minus b. See if anything's factorable. Doesn't look like it to me, though. As far as canceling goes, all you can really do is cancel down the b's here. So canceling those down, what do you have left? Is you have b plus a over a times 1 minus b. And that'd be your solution. All right, same thing for the next one. Break this up basically into 3 problems altogether. So I'm going to deal with my numerator. So 2 over x minus 1 over 1. Get your common denominator. So second one needs an x in it. So this would just be 2 minus 1x over x. Okay, there's my numerator. Do the same thing now with the bottom. So we have 1 over y minus 3 over x. Get your common denominator. So first one needs an x. Second one needs a y. So this would be x minus 3y all over xy. So there's my new denominator. Last thing, divide. Again, you're taking the top one, dividing it by the bottom one. So take your 2 results. My top one is 2 minus x over x. And now I want to multiply by the reciprocal. So here's my setup. And again, as far as multiplying goes, nothing's really going to cancel in this case. Nothing's going to factor, at least. Canceling wise, though, the x's do cancel. So those x's go away. So what do we have left? We have y over 2 minus x over x minus 3y. And there you go. There's your solution. All right. I'll let you guys try the last one if you want to try that one on your own. Get some extra practice. The answer you should get, though, for C comes out to be just x plus y over x minus y, and that would be your solution. So if you wanted to give the last one a shot on your own, again, try that out, see if you get that answer. But otherwise, thank you for tuning in today, and we'll talk to you next time.